Good evening, everyone. Welcome back to CS196. So I'm going to quickly go over our objectives before I start. So today we're going to go over APIs. That's the main focus of today. So what are APIs? Why do we use APIs? How do we use APIs? And then to fully understand APIs, we're also going to talk about HTML requests and JSON and touch on XML. If these are a bunch of acronyms that make no sense right now, don't worry about it. We're going to cover everything today. So what are APIs? So API stands for Application Programming Interface. And I'm going to use this example from this video. You can watch this later. It explains it very, very well. I thought it was a great example. So imagine you are at a restaurant, La CS196. So you are over here. You have a menu full of requests. Those are your food orders. And then the kitchen is what's going to handle your request. And you get food out of it. Seems pretty obvious. But there is something missing here. There's a key vital component missing from sending your order to the kitchen and getting what you want. And that's the waiter. So like in any other restaurant, you're going to look through the menu, find what you want, make that request to the waiter. The waiter will take your request, pass it off to the kitchen. The kitchen will do whatever they need to do, make your food, give the food back to the waiter, and get that back to you. And yeah, we're happy. We got our meal, everything went smooth, and it was pretty easy to do. Similarly, when we have a system like this, so you over there are the client and there's a server, and like this, although it looks like they're very close by, the distance between the client and the server doesn't matter because we use APIs. So our server could be on the other side of the country, could be on the other side of the world. It doesn't matter because the use of APIs reduces the complexity and makes sure that regardless of where we are, we can make this work every single time. So let's go back to our example. So we have a request here. That's the little green ball. We send our request to the server. The server processes our request, gets us the response that we want, the data that we want, anything that we need from the server, and we'll pass that back to the client. And now we have our response. But again, how did this response get moved around? Who's handling it? How are we getting exactly what we need? It's pretty difficult to handle, like send millions of bits over and get that back. But the waiter here is our API. Using the application programming interface, we can reduce the complexity of having to send data over, and we can outsource a lot of our work because the API makes it so easy. So let's give a real-world example of this. Like, where have you seen APIs in your day-to-day? So everyone wave at Sami. Sami. So we have Uber as a really great example. So this is a screenshot directly from my Uber app. So I cropped it off so I don't want you guys to know my address. But notice in the bottom right corner, it says Google there. So last I checked, which was a couple hours ago, Google does not own Uber yet. Actually, Alphabet, Google's parent company, owns 5.8% of Uber, so the more you know. But no, Uber does not own Google. There's no affiliation there. But what Google is using is it's using Google Maps API. And you're probably wondering, why would Uber, a company that is worth over $1 billion, need to use code from somewhere else? Well, here's why. Google has arguably the best map software in the world. There's around 32 satellites around the world, which Google pays for, or rents out. I guess I'm not really sure how satellites work. But it's 32 satellites that Google pays to give you updated information and give you live data. You can get directions. Uber driver uses the directions using the shortest route using map and traffic data with constantly updated maps. And secondly, it's very easy to use. Once you have the API, there's no need to update the maps or to handle any of the complexity of running GPS software. So even a huge company like Uber will outsource their work to APIs. But why do we want to use APIs? Why do we care? We're learning to program. We don't need to outsource this. Well, it's because of one very important fact, and that is good programmers are lazy. And what I mean by that is that you're not going to sit there and just copy code off GitHub for every assignment you have to do. Definitely don't do that. What I mean is that good programmers are efficient. You're not going to waste time writing the same code over and over again. You're not going to manually input data by yourself. You're going to handle that using a script, et cetera, et cetera. Here's a little comic I thought was pretty funny. Anyways, being a bad programmer might not stop the robo-apocalypse, but it will save you a lot of time and make you more efficient overall. And I'm not the only person who thinks that. Larry Wall, the author of the Perl programming language, says, the most of you are familiar with the three virtues of a programmer. With the virtues of a programmer. There are three, of course: laziness, impatience, and hubris. And again, these sound like bad things, but all of these three virtues are what make you more efficient and more likely to get to your outcome faster. So let's look at the advantages of using APIs. So firstly, automation. APIs allow us to automate tasks without having to do the automation ourselves. It's very nice to be able to outsource work when code for that already exists. There's no need for us to reinvent the wheel over and over again. Secondly, efficiency. API allows developers to access powerful tools and create new features and publish them very, very quickly. So normally, if you want to add a search bar or something, creating a search engine on its own is very difficult. Ask Google. And then having to implement that into your app is also very difficult. So by using APIs, we can be more efficient with our time. Finally, adaptability. APIs save companies and developers a lot of time and money because changes can be published and made very quickly. So take, for instance, a client suddenly wants to add a new feature and they say it has to be done in 2 days. If you have to write something from scratch and implement it and test it, it will take a very long time. So it's nice knowing that if you call an API, you have working code. It's a black box that gives you exactly what you need, and you don't have to test and waste more time. And again, it comes back to this idea that good programmers are lazy. There's no point trying to reinvent the wheel every time we want to do something. My slide isn't moving. Okay. Again, there's no need to reinvent the wheel. You just have to use APIs to make your life a little easier. And also for your projects, that's the key thing I wanted to hammer on. You guys are totally welcome to use APIs for your projects because a lot of the things that you might need are too complex to make in a semester or already exist. There's no need to waste your time writing it again. So we're going to take a quick break from APIs to talk about HTML requests. So firstly, what is HTTP? So HTTP stands for Hypertext Transfer Protocol. And this is a protocol that's designed for communication between clients and servers. So let's look at what an HTTP request looks like. So you don't need to understand the bulk of this. I just wanted to give you guys a picture of what it looks like. So at the top, you have the request line, and that's specifically what you're doing. You notice we have a keyword there, get, followed by the URL, URI, and then the HTTP version. Underneath that, we have the request headers, which is information about the request, general stuff. We can ignore that completely for our purposes. Then there's a blank line, which separates the header and body, and then we have the request message body. So this is what you, the client, are sending out to the server. And then you'll get back an HTTP response message. So this is what it looks like again. Again, a lot of this you don't need to remember. But at the top, we have the status line, response headers. The very important thing that we do want, though, is the response message body, because that contains the data of the information that we're trying to get back. So let's talk about 4 main HTTP methods. So there's more than this, but these are the 4 that I want to talk about just because they're easy to explain and gives you a good introduction to them. So firstly, we have the get method. So you use get to request data from a specified source. So that's the main thing. That's all it does. Get gets you what you want. Pretty self-explanatory. The query is in the URL of the get request. So you'll do get URL and then some kind of query string. And so an example that I'm probably going to use later today is the Google Custom Search API. So the way this works is that you'll use get, pass the URL, and then the parameters. And in the parameters, you'll have things like how to identify yourself, the search query, et cetera, et cetera. So get requests should never be used when dealing with sensitive information. And a reason for this is because this data can be cached in your browser history and in the web server logs. So if it can be cached, it means it's just stored later. So anybody can come back and try to use malicious code to take it out of your server, your browser, sorry. And get requests are only used to request data. You cannot modify data using the get request. Does that make sense? Any questions so far about anything? Okay. And now we're going to talk about the post method. So you use post to send data to a server to create or update records. So again, get is to get stuff, post is to update things on the server side. So data sent to a server via post is stored in the body of the HTTP request. So that's different to the get request, which is in the URL. This is in the body, which is just underneath the header. And post is a little safer than get because you can't cache a post request. Therefore, anything that you do with post will not be stored and saved most of the time. Now put. I use put to request data from a specified, oops, sorry, that's a typo. Use put to change data on the server side. So why do we have put and post then? Well, put requests are idempotent. So what does that mean? This means that calling the same pull request multiple times will always have the same result. Whereas if you called post multiple times, you could have repeated values. So let's say you had a for loop and you just kept doing put over and over and over again to say, that guy's name is Sami. You can do that over and over again, right? If you use put, you only see that one time. That's exactly what you want, even though it's a bug in the code. If you use post, you'll have a huge list of a bunch of people all call Sami with no new information. So put is for indefinite requests. Finally, we have the head method. So this is almost the same as the get method, except without a response body. So that doesn't make sense. I thought get was just for getting things, getting it to us, right? That's probably what you guys are thinking. Well, head is good when we want to just see what we're getting before we have to download the whole file. So for example, if you're about to download a huge JSON file, instead of wasting time actually downloading this huge thing, you can use head to check first and then download it once you know exactly what it is, or reject that download. But how do APIs actually send us the data that we want? Well, there's two very popular formats for moving data around. Firstly, we have JSON, which is JavaScript Object Notation, and XML, Extensible Markup Language. So we're going to focus on JSON just because it's very popular now. So JSON is the standard for serializing data object in human readable format. JSON can be read very easily by humans and computers because of the way it's formatted, and you'll see that when we get onto it. It's popular as a common format for browser-server data exchange. It's used by different languages systems beyond just JavaScript, so don't worry if you don't know any JavaScript. You can use this in many, many different languages. The documents you have are in a nested structure, and the basic idea is that it's made up of key-value pairs. XML, on the other hand, is an older data format that's still very powerful and still widely used, but one that we're not going to focus on just because a lot of the APIs that you will see will not be using XML. Again, the documents have a nested structure, and the basic structure is that you have nodes. You have a big node like this with subnodes inside it. So let's look at the JSON structure. So JSON is made up of arrays and objects. So what's an array? Well, array, we've seen this in multiple languages, is just a list, a comma-separated list surrounded by square brackets. An object, on the other hand, is surrounded by curly brackets and contains a comma-separated list of key-value pairs. And a key-value pair is in the format of key/field name in speech marks. So you have to have your key or field name in speech marks and then a value. So let's see this in practice. Or first, let's go over data types. My bad. So there you can have different kinds of types in JSON. So here's the main ones. You can have integers, floating points. Those are your numbers, whole numbers, decimals. You can have a string, which must be surrounded by double quotes. You can have booleans. So that's the keywords true or false. And notice here that the T and F are lowercase. That's important because if you don't do it, you might have errors. You can have nested arrays, nested objects, and then the null value. So those second last two, are pretty powerful because that means you can have a huge JSON object with multiple JSON chunks inside it and multiple arrays inside it because you have this nested structure. And that allows you to send a lot of data very quickly, and it's very easy for computers and humans to read. So let's look at this UIUC student JSON. And this is correct JSON. It gets validated and everything. So as you can see, it's pretty easy to read. We can see that at the top, we have the name, which is John Doe, the UIN, which is an integer, which is a string and a bunch of numbers, their email, which is, again, a string. I'm going to skip classes for now and then go to the bottom, which is the foreign language completed, which is true. That's just a Boolean. But now let's take a look at the classes, because that can be a little confusing. So notice that there's a square bracket just outside classes. So classes is an array. Great. So we know what classes holds a list of something, a comma-separated list of something. But what's inside classes? Inside classes are objects. Notice the curly brackets. So the classes is an array holding a bunch of objects, which are the classes. So we can see that inside the object, they'll have a name and a grade, et cetera, et cetera. And this shows that how powerful JSON can be, because you can have nested structures like this to store a lot of data into one document about one person. So you have the object as a whole, the JSON thing as a whole, and you see it's surrounded by curly brackets. These are the key value pairs. All different colors are different key value pairs. We have our array as a whole. So the yellow indicates where the array starts and ends, and we have the colored objects inside. Now, how do we tie all of this together? Well, firstly, we want to read the API documentation to get access requirements. So what does that mean? Well, different APIs are very different in how we use them, but most of them involve getting a URL and API key. So let's talk about API keys are next. So often APIs will ask you to uniquely identify yourself so they know who you are. This is so that if you paid for the service, you get exactly what you paid for, or if you're an anonymous user, you're not going to abuse their systems and DDoS them or crash their systems. So you'll probably need to get an API key. Thirdly, you want to generate a URL from the API documentation. So similar to the GET request, we want to have a URL that we can send requests to. So you can find this in the documentation. Next, this is optional but highly advisable. Optional but highly advisable is you want to test your request either in your browser or using a tool like Postman. So we're going to use Postman later on. And you test using HTML requests and check the output, which is often in JSON. That's how we tie everything together. And finally, you want to integrate this into your program. And this is, although it's just one step, is actually a really, really big step because you have to firstly test everything and then try and put that thing that you've made into your app without breaking everything else. So now let's go into a demo using API calls. All right, so let's first look at this website over here. So this is a website called Request. It just gives you a bunch of dumb APIs. These don't actually do anything very important, but you can use it to test your own API calls. So let's go over here to this thing called single user. So we can see it's a GET request. And let's say we wanted to see what the URL was. We can click over here. And if we were to make the GET request, this is what we're going to get. We're going to get this JSON string. So let's do this in Postman, because let's say we weren't able to open this link like this. We wanted to see more information about it. So I'm going to copy this link, and this is Postman over here. I can open a new request here. Let's just call it example get. I'm going to create this, and now I can paste the URL here, and we see that we can change the kind of request that we want to make. We're just going to stick with get for now, and when we send it, we get the JSON data. And as we can see, it's automatically pre-printed, so we can see very clearly what this person JSON holds. Any questions about this? Okay. But this isn't very useful. This does not give us a lot of information. So let's do something that's more applicable. So I'm going to talk about Google Custom Search. So Google's Custom Search is a feature that lets you make your own search engine that you can either use to search the entire web or just a couple websites. So if I go to Geeks, for instance, this search bar here at the top is a Google Custom Search bar. It's built off of Google's own search engine, but only searches Geeks web pages. So over here we have the search engine. It's pretty basic. We can make searches like, let's say, API. We get a bunch of results here, or computer science. We get a bunch of results here. But how can we use this in our own programs? Well, to do that, Google has its own URL path we have to follow. So if I go to Google Custom Search API over here, we see that they specify a format for us. So I'm going to look through documentation, and we see this is how they want us to pass this to our API. We want to get a URL like this and put the parameters at the end, so because it's a GET request. And we can see that the way they want us to do it is we have the URL, we give our API key over here, we put our search engine key over here, and finally our query at the very end. So I've already done a query over here in Postman that we can take a look at. So notice that I blurred out my API and my search engine key because I don't want to get hacked. And then the query that I did was CS196. So let's look at the JSON output. Let's make this a little bigger first. First, I'm just going to copy this into VS Code. Let's take a look at this JSON. Oh. Desktop. Okay. So if we look at the JSON, we get a huge amount of data here. So firstly, let's make this a little simpler for us. Using VS Code and other ID, you can simplify your JSON queries into the main chunks. And this is again showing JSON's nested feature. We see we have the URL here, and we have the kind. So the kind is a custom search. Now we have the URL. In the URL, we get exactly the query that we made. Pretty basic stuff. In the queries, we see that we made the search here. We get the total number of results, and then other information regarding the query that we just made. Now we can look at the actual information here. Search time, formatted search. And then finally, items. So items is what really takes up a lot of space. This is all the results that Google found for us. And we can see the top result here is this link here. So let's paste this, let's get this link. We paste it into Google. It's a 196 website. So that's pretty self-explanatory. The Google custom search engine lets you make queries on the fly using Google's own software. So any questions about the custom search API? Or anything regarding the API so far? Nope, okay. Then we can get right into the Kahoot. So let's do the Kahoot. Is everyone in the Kahoot? Raise your hand if you're not in the Kahoot. All right. Okay, I don't know who got this wrong, but API stand for Application Programming Interface. We said that at the start. Okay, great. So everyone got it right. So there's two answers here. So firstly, let's say why the other two are wrong. So maze game is solving a maze using AI locally. Again, if you're not making a request to something external, it's not an API call. Similarly with Instagram applying filters to a photo, I've tried this. You can do this offline with no Wi-Fi. So again, no API call. So a flight website checking the offsite servers to see what flights are available. I think Kahoot cut off my the last couple characters. So when you go into a flight website and you look for any flights, you have to make an API call to all the different flight companies to see which flights they have given a date and time. Similarly, with sharing something to Facebook on an external website, Facebook doesn't hand out its source code to every single company that wants to use a share button. It just uses an API call because it protects itself while giving external website the functionality to share content to Facebook. That's the leaderboard. Who got this wrong? Speak to me afterwards. Yeah, so you can definitely use APIs in your 196 projects. It's totally okay. Obviously, do not just take a whole project from GitHub and give that to us because we will find out. But you're totally allowed to use APIs and other libraries. Okay, so this one is a little hard. The query string for a GET request is passed in the URL. So if I go back over here for a sec, if we look at this directly, in the diagram here, you see the GET request is directly in the request line or directly in the URL. And we also saw that with the Google custom search. Okay, so GET requests. I think one person's like messing with me. I'm not sure who this is. You use GET requests to get data. It's like in the name. You get data. You're not changing anything. It's not Sami. Okay. All right, so post is safer than get. So both of them aren't ideal. Neither of them are perfect, and you should definitely, if you're setting passwords and stuff, should never just use post. But GET queries can be cached in both the browser and the server web logs, whereas post cannot. So it's slightly safer, but still not that safe. That round really changed the leaderboard. All right, so let's try this right. So indefinite means, like with the put method, it just means, I gave away the next question. It just means that if you try to do the same command over and over again, like inserting Sami into a database over and over again, it won't happen. It'll just have one result, and it will not keep appending more and more copies, unlike the post method. All right, okay. Let's, okay. So it's 6, 7, 8, 9, that order. I'm so sorry. Oh, 6, 7. I'm really sorry about that. We could probably, I don't know, we could probably leave this one for like extra credit or something. So full disclosure, the next two are also JSON questions, and I hope they're formatted a little better. How many toppings are on this pizza? Okay, that one is pretty tricky, so let's take a look at the image. So if we look at the toppings here, it's an array. So we have the square bracket here, square bracket here. But the array is not like in Rust. We can have multiple different data types. So you notice here we have this pizza object as one of the toppings, and then peppers is another topping. So 2 toppings was the answer. And I again just gave the answer to the next one. Okay, let's look at the image again. I did just say this, but yes, one of the toppings is a whole extra pizza. So if we look over here, on the topping section, we have another object as one of the toppings. And this is a pizza object because it has a size, crust, cheese level, toppings, and then also peppers on top of the pizza. So yes, this person did order a whole extra pizza as a topping. Oh, sorry, I skipped the leaderboard. XML and JSON use a blank All right, great. So yeah, XML and JSON use a nested structure, and that's why we can have really crazy things like putting objects, and having pizzas as pizzas toppings. All right, so good job, guys. You do not put speech marks. You have to put speech marks around a key field in JSON. So if you have like name, for instance, and then my name, you have to put speech marks around the name and also the name because it's a string. All right, let's take a look at the results. Okay. All right, so congratulations, the top three and the runner-ups. Let me play this for a sec. All right, so the key things I wanted to hit on today were the APIs are a really powerful tool that you can reuse. So you can reuse code instead of having to reinvent the wheel every time. Also, you can use in any language. You can use in Python, Rust, Java. It's very expansive. And finally, you can use these in your projects. We're not going to say you're cheating or anything if you use an API. APIs are used in industry as well, so please, you're more than welcome to.